Hello. Okay, I have had people request that I make a video on how to solve a stoichiometry problem. So, step one of every single stoichiometry problem is that you have to start with a balanced equation. I have also gone ahead and calculated the molar mass of our two reactants. To be honest, if I was doing a worksheet, I would probably also calculate the molar mass of the products as well. You're going to use that over and over again, so you might as well go ahead and do it now. All right, here's our problem. How much water is needed to fully react with 350 grams of titanium chloride? Step one, start with a balanced equation. Step two, identify and write down your given. Guys, the given is the thing in the problem that has a number, but it is not only that. You need to write down the number, you need to write down the unit, and you need to write down the substance. And I always run into students who say, I don't want to write all of that down. And that's fine, you don't have to. But you will make mistakes and it will be hard until you do write all of this down. I'm gonna put that over one. I need you to go back to the very beginning of this unit. We started out with mole ratios. We started out by figuring, if I'm looking at titanium chloride and I am looking at water, what is that mole ratio? And I found out that the mole ratio of titanium chloride in this equation is we have 1 mole of titanium chloride and 2 moles of water. But I don't have the number of moles of titanium chloride. So before I can use my mole ratio, first I have to convert from grams to moles. Okay, so that is the purpose of this step, is I have to get to moles so I can compare my two substances. So, anytime I want to go from grams to moles, I'm going to use the molar mass. I have grams on the top, so I know grams is going to go on the bottom. Here is my molar mass of titanium chloride. I'm going to copy that down, 189.70 grams, and that is the mass in grams of 1 mole of titanium chloride. Well, grams of titanium chloride just canceled out, and now I know I have moles of titanium chloride. Now I'm going to use my mole ratio, which tells me that for every 1 mole of titanium chloride, I need double the number of moles of water. So I've now canceled out moles of titanium chloride. So now I have moles of water, but if I'm trying to actually perform this reaction, I can't just go grab 2 moles of water. I have to use the mass to figure out when I have 2 moles of water. And the way I'm going to do that is, again, the molar mass. But this time, I'm starting with moles. So I'm putting 1 mole of water on the bottom. And now I know I put my grams of water on the top. I'm going to double check that I did everything, and the only thing that's not canceled out is grams of water, and that's what it asked me to find. So I know I set this up correctly. And at this point, I'm going to grab a calculator that hopefully is working. And if not, I'm going to press on and clear, and that will usually get it to wake up for me. I am multiplying everything across the top, so 350 times 2 times 18 equals that number. I'm going to multiply everything across the bottom, which is just that number. And now I take the top and divide it by the bottom. And my calculator turned off. So we're going to try that one again. And I'm going to go grab a new calculator. Moments like these you don't get on the other channels. Okay, and I end up with 66.42 grams of water. So then I would get a scale, I would measure out 66.42 grams of water, and that is going to be enough water to react with my 350 grams of titanium chloride. So now I could actually perform this experiment. That's the point behind all of that. That is the purpose. It's not just math just for the sake of math. We're actually trying to do it for a reason. All right? Thank you very much.